This is a bit complicated, so I would take some time to do this. So we have combustion. Alkanes undergo combustion, and the next one is substitution reaction. Then alkanes, we know it's very unreactive, so there isn't too many reactions. So you don't have to learn that many reactions too. So this substitution reaction is a special reaction that alkanes go through in the presence of light, and light is considered a catalyst. Light, or they sometimes use the ultraviolet light. So are you familiar with the term catalyst?
No.
So a catalyst is a substance or a condition that makes a reaction faster. It can be a condition that means light, or it can be a substance you add into the reaction and then it makes the reaction faster. Then a catalyst, right, is usually not used up in the reaction. So for example, you can have maybe say hydrogen peroxide. It will decompose into water and oxygen gas. I think so. I think this is a reaction. So the decomposition itself, if you leave it there, sit on the table for a while, right, the reaction will only progress very slowly. So if for the reaction to take place, you're gonna leave it down there for maybe a few days. So do you have that kind of time to sit down there and wait for a few days for the reaction to happen? Don't have, huh? So what you do is you throw in some substance X called the catalyst. So then after you throw in the catalyst, the reaction become faster. Then it will decompose into water and oxygen within shorter time, maybe say half an hour instead of a few days. Then you get your product, oxygen and water. Then after that, right, you will examine at the end of the reaction, you will see that the catalyst X is still in the beaker and is not used up. Then you can pour it out and then recycle the catalyst. So that is a catalyst. It's a substance that makes a reaction faster, but it can be recycled, it can be reused because it's not used up by the reaction. Okay, can, huh?
Yeah.
Yeah. So in the case of a substitution reaction, light is a catalyst. That means you take the reaction, you put it under light, you shine, then the reaction becomes very fast. So a substitution reaction, what it does is each hydrogen atom in the alkane is displaced by a halogen atom one at a time. Means if I have hydrogen, 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 hydrogen. Then I add, say, bromine. So when I add bromine, so hydrogen get displaced. That means it get pushed out of the molecule. Then after that, it get replaced by the bromine. Then after that, we got another bromine, right? Or another bromine molecule will come, and then it will replace the other hydrogen like that. So the rough idea is like this. Bromine goes in one at a time, then the hydrogen get kicked out one at a time. Okay?
Yeah.
The idea is like this. So we have examples here in detail. We have to slowly talk about it. So the reaction between methane, this is the alkane that we are using this time around. It mixes with chlorine gas. Okay? So stage 1, we have methane. First, I draw methane. Then it says it reacts with chlorine gas. So what happened is this chlorine will split into two. It breaks up. Okay. So then it goes around, go to our methane. Then the chlorine will push the hydrogen out. So when that happens, that hydrogen gets pushed out, the chlorine goes in. Then, so you have the hydrogen floating around, right? And then there's another chlorine down there floating around, right? So this hydrogen and this chlorine will come together and join together, then become like that. Okay?
Yeah.
Yeah, you get the process, right?
Yeah.
So if they want the chemical equation, that will mean is CH4 plus Cl2 gives you CH3 Cl
Yeah.
plus HCl. That is the first stage. Okay, so the first stage will form CH3Cl. So now CH3Cl is back because the reaction vessel has a lot of chlorine gas. CH3Cl will meet another chlorine molecule. So now what happens again is the process repeat itself. The chlorine molecule will break up. This one will go out, go to the CH3Cl, targets the other hydrogen, and then release it, push it out. So when that happens, you will have Cl going in to replace that hydrogen, and the Cl that was there before, then like that. Then there is a hydrogen floating around right now, and there's another chlorine gas left over from the other side. That two will come together and form HCl again. So your second step chemical reaction is CH3Cl plus Cl2 gives you CH2Cl2 plus HCl. Okay, so with more chlorine gas coming in, right, this reaction will continue until this and this also are replaced by chlorine, and your final product will be CCl4. When all the hydrogen is replaced, then the reaction stops. Okay, so that means this process, right, the stage 2, there's a stage 3 and there's a stage 4. Okay, so I want to go back to stage 1 again and then discuss another thing. Chlorine gas has an appearance. It has some color, so it's greenish yellow. Okay, so now methane is usually colorless. What color change will you observe in this reaction?
Turns from colorless to greenish yellowish color.
No, this one greenish yellowish color goes into the colorless gas. So the chlorine gas is no longer chlorine gas because it forms this. So the greenish yellow will disappear. So this will be chlorine will decolorize.
Greenish yellow decolorizes.
Yes, will decolorize. So the more as the reaction continue, right, you will see that lesser the chlorine gas become lesser and lesser greenish yellow. So it will eventually become colorless. So it reacts with chlorine. The same process also happens with bromine. Number one, they say what is a substitution reaction? I will give you the standard definition. It's a reaction in which one or more atoms of an organic compound is replaced by one or more other atoms. Okay?
Yes.
Yeah, so it should be fine if you see this question, you just give them something like that. Okay, this one, I talked about it earlier. Name the condition needed for the reaction to take place between alkanes and chlorine. Presence of light or UV light. Describe what happens during a substitution reaction between alkanes and chlorine. The magic word describe. So in a few sentences, you can describe what happens, and then we will just work on your answer. Hydrogen atoms in an alkane are replaced by chlorine atoms one at a time. So then the reaction will stop when all the hydrogen atoms are used up, right, or replaced, or all the hydrogen atoms has been displaced. This is what we do just now. Complete the following substitution reaction. Yep. Presence of sunlight. This one. Now it looks a bit different because instead of methane, right, we can have another alkane molecule, and this is the ethane molecule with a few bromines inside. So this is, there's a name for this. This is dibromoethane. Yep. Can the bromine be placed here? Can I place the bromine on this hydrogen instead?
No.
Yes, you can. You can because the bromine can come in to replace any hydrogen atom, and the reaction will stop when all the hydrogen is replaced. Okay, so if your answer is like that, right, it will be accepted. So if you put the bromine here or even here, right, one at a time, so one each, the answer can also be accepted. It's not wrong at all. Okay, it does not mean that you have to stick to the first carbon. You can go to the second carbon and then put the bromine there. It's also fine. This is a bit tricky. It says that 3 Cl molecules are used. Will your equation be balanced? I didn't talk about balancing the equation because we only add in one at a time. But now because it's three molecules, right, then you will have to check whether it is balanced. And then because for every chlorine molecule we add in, we replace one hydrogen. So 3 molecules of chlorine added in means it's probably 3 hydrogen atoms are replaced. Yeah. Write a chemical equation to represent a conversion of 1 mole of C2H6 into C2H3Cl. What it means is you're gonna convert C2 C2H6 into C2H, Cl. So because it's substitution reaction, so you need to put in Cl. Then it kicks out HCl, right? So we have we replace three hydrogen, so it's 3C like this. When 3 is replaced, 3 hydrogen get kicked out, so then 3 will be left over on the chlorine side. So it's like the drawing wise is like this. So if you want to write a balanced equation, you write this plus chlorine gas gives you, the product is given to you already. You can just do it like a normal balance equation, HCl. You get this? Then times 3 here, then you times 3 here. Then you see that carbon is balanced. 6 chlorine, 6 chlorine, 6 hydrogen, 6 hydrogen. Like that. Okay?
Yeah.
Okay, so what is the first step if you are given this question?
Write down the equation first.
Write down the equation first. So this is a combustion reaction, right? So what's the formula for butane? It has how many carbon? The general formula for alkanes is CnH2n plus 2.
Yeah.
So what is the formula for butane?
Butane is the C4, right? C4H8, right? Is it
The formula is here. So C4H how many?
H8, right? Is it
2n.
or 10?
So H10 plus oxygen gives you carbon dioxide and what's the next product?
Carbon dioxide and is it hydrogen?
This is
No, more than
this is combustion. So what's the product?
water, H2.
Water. Okay, so how to balance?
4 CO2, right?
This one is balance carbon, balance hydrogen, then balance oxygen.
4 CO2, then 5 H2O.
5 H2O, then
8 plus 5. That's the odd number, I think.
so
Must increase
8 plus 5. So it's how much?
13. So
13.
it's odd number.
So 13 over 2. Odd number cannot, so 13 over 2. Then after that, then you get rid of the over 2. So you multiply everything times 2. 8 CO2 plus what? 10 H2O. So then what's next? Because this is at high temperature. So this is a gas. This is a gas. Then this is a gas, and this one is steam. So all 4 reactant and product are in the gaseous form. So how?
Oh, they're all in gas.
Yes.
So it's the 24 dm cube down, right? Times 30.
So when it comes to gas, then we got the 24 dm cube one, which is to find the number of moles, right? Okay. Then there's another thing, because all the reactants and products are in gas, then the mole ratio is the volume ratio.
Okay.
Yeah.
Yeah. So
Remember that, huh?
10% of carbon dioxide.
So we have butane and carbon dioxide. So we find the butane to carbon dioxide ratio is 2:8. So then that means mole ratio is volume ratio. So it's 10:10 so times 5.
Yeah, times 5.
Times 5. So
40.
here. Like that. You might want to take note of these. They say when a mixture of an alkane X and chlorine is exposed to UV light, an organic compound C2H5Cl is formed. They say identify X, so that means you have to name X, then you draw the structural formula. Structural formulas are like this kind is a structural formula. Ethane, because you use chlorine and then 1 chlorine goes in, then there's 2 carbon. Okay, since I've talked about it just now, so this one you're on your own, but you have 2 here, 2 here, 2 here, 2 here. Do you need that 2 to TL2 here? 6. You don't need the 2 because simplest form, so you don't know. Okay.
Yeah.
So suggest the structural formula of another organic compound form. You can see 2H5Cl already, so that is one compound that is formed. So it is possible to form other organic compounds when you have this with chlorine. Then it suggests that means you can have more than one answer. Your X is ethane, so that means you start with this. So when you react with chlorine, you get HCl, yeah. Then you get a chlorine and then H. Another reaction could happen when this product reacts with more chlorine. Then what happens is this will become Cl. you can have this. So this is one possible other product. So if you write this, it's fine. You can have a 3-chlorine out there, answer also fine because it's a suggest question. But there must be 2 carbon because if it's only 1 carbon, right, means you started with methane. But I mean, in your question, there's no methane inside, right? So you cannot use this as your answer. So you have, if you have, and your answer, other answers that is acceptable is any answer with 2 carbon and any amount of chlorine. Okay?
Yeah.
So you can have this. You see the answer here at 2 chlorine, but you can have other answer with 3 chlorine possible.